You know, in science, we're often hunting for those simple, clean, yes or no answers. Does this pill work? Is this method better? But let's be real, the world is rarely that black and white. So today, we're going to dive into the incredible power behind a phrase you might think is a cop-out, but is actually one of the most sophisticated answers in science. It depends. Okay, so to kick things off, here's a real finding from a pretty mind-blowing study. I mean, think about that for a second. It feels completely backwards, right? You'd expect the exact opposite, but this isn't some fluke or a mistake. This result, this puzzle, is the key to understanding a really powerful way that scientists uncover the truth. So what is going on here? The answer isn't just about bad cops or anything like that. It's about how different ingredients, different factors can mix together in ways you'd never predict. To really untangle this, we have to move past a simple this causes that mindset and embrace a much more powerful way of seeing the world. Right, so to get to the bottom of really complex questions, researchers can't just look at one thing at a time. It's not enough. They need a special kind of experimental design that lets them see how multiple things work together, and sometimes how they clash. A simple experiment is great for some things. You know, you add fertilizer, the plant grows taller. One cause, one effect. Super straightforward. But what happens when the real world gets messy? What if the fertilizer only works with a certain kind of plant and a certain amount of sunlight? That's where a complex, or what scientists call a factorial design, comes in. It lets us test multiple causes all at once to see how they combine and interact to create the final outcome. Okay, so let's get back to our interrogation puzzle. It's from this fantastic study by a researcher named Cassin. He and his team wanted to test something called confirmation bias, the idea that what we already believe can totally change how we behave. So they set up this classic 2x2 experiment. They messed with two key things. First, was the person being questioned actually guilty or innocent? And second, what did the interrogator believe about them? Did they think they were talking to a guilty person or an innocent one? Now, when you have a complex design like this, the first thing you look for are what we call main effects. It's a fancy term for a simple idea. What's the overall impact of just one of your variables, all by itself? Just ignore everything else for a second. Think about baking a cake. What's the main effect of flour? Well, on its own, it's just dusty powder. We're looking at each ingredient individually before we see how they bake together. And here's the first main effect they found. It's a really clear one. When interrogators thought a suspect was guilty, they asked way more leading, guilt-presumptive questions, about 3.6 on average. Compare that to when they thought the suspect was innocent, only about 2.6. And this happened no matter if the person was actually guilty or not. So check one box. The interrogator's personal bias had a really direct, obvious effect. Totally makes sense. But then we get the second main effect, and this is the one that started our whole mystery. When the researchers looked at the other variable, the suspect's actual status, they found that overall, interrogators pushed way harder and used more aggressive techniques when they were questioning innocent people. It's so weird, right? Why on earth would that happen? See, just looking at the main effects isn't enough. It's clear we're missing a crucial piece of the story. So this leads us to that missing piece. And honestly, this is the most exciting part of a complex design. It's called the interaction effect. This is where we stop looking at the flour and the sugar separately, and we finally look at what happens when you put them in the oven together. An interaction effect is exactly what it sounds like. It's when the effect of one thing changes depending on some other thing. The effect of turning on your oven depends on whether there's a cake inside. The effect of adding water to a mix depends on whether it's concrete mix or lemonade mix, right? It's this dependency, this combination that creates something brand new and totally different from its parts. So let's look at the actual data for how much effort the interrogators put in. Just follow me here. Look at the top row, the suspects who are actually guilty. The numbers are almost identical, right? 5.64 versus 5.56. It didn't really matter what the interrogator believed. But now, look at that bottom row, the innocent suspects. When the interrogator thought they were innocent, the effort was 5.85. But when they thought they were guilty, whoa, the effort jumps all the way to 7.17. That's not a small difference, that's a massive leap. Now, staring at a table of numbers can make your eyes glaze over. But watch what happens when we turn this into a graph. The interaction just pops right out at you. The secret telltale sign is when the pattern for one group looks totally different from the pattern for the other. And there it is. This is our aha moment. Look at the bars for the guilty suspects on the left. They're practically flat. The interrogator's belief just didn't really move the needle. But now, look at the bars for the innocent suspects on the right. When the interrogator expected innocence, the effort was low, but when they expected guilt, that bar just skyrockets. So the effect of the interrogator's bias wasn't universal. It depended entirely on whether the suspect was innocent or not. And just like that, the puzzle is solved. It seems that when a guilty person is interrogated, their behavior kind of confirms the interrogator's suspicion. But when an innocent person is accused, they get defensive, they get nervous, and the biased interrogator reads all that as a sign of guilt. This makes them push even harder, which makes the innocent person act even more defensive, and you get this terrible, dangerous feedback loop. The bias wasn't just there, it was supercharged, in the absolute worst-case scenario. So look, this is way more than just a neat statistical trick. Understanding interactions like this completely changes how we think about the world. It gives us a much richer and, frankly, a much more accurate picture of reality. Interactions are absolutely critical. The world is complex, so our theories have to be complex too. They help us make sense of why, for example, two studies on the same thing might get totally different results. Maybe a new teaching method worked in one school but not another because its effectiveness depends on class size. Most importantly, interactions tell us where a finding applies and where it stops applying. They draw the map. This really gets at a huge idea in science called generalizability. Basically, how far can we stretch a result? If there's no interaction, the finding is probably pretty solid and applies broadly. That interrogator bias towards asking leading questions, that was pretty general. But when an interaction pops up, it puts a big fence around the finding. The interrogator's bias led to a massive increase in pressure, but only for innocent suspects. The interaction tells us exactly when and for whom that effect is true. And here's something really clever. Researchers can use interactions as a kind of detective tool to figure out why groups are different. By introducing a new factor and seeing how different groups react to it, they can get some seriously powerful clues about what's causing the original difference. It's a huge step towards understanding real causality. Okay, so this is all really cool for scientists in a lab. But what does it mean for the rest of us? How can we actually use this idea in our own lives? Well, it all comes back to where we started. The phrase "it depends" isn't a weak answer. It's not a dodge. It is very often the most precise, the most intelligent, and the most accurate answer you can give. It shows that you get it, that you understand that simple, one-size-fits-all effects are rare, and that context is everything. So that's what I want to leave you with. The next time you see a headline that promises a simple solution, "This one food will make you live longer, the single habit of all successful people," I want you to pause and think like a researcher. Ask yourself, on whom, for whom does this work? Under what conditions? What is the it that this amazing effect depends on? Because 9 times out of 10, the most fascinating and the most important truths aren't in the simple answer. They're hidden in the interaction.